All right, in this movie, we're going to work on some free fall problems, and so if we look at the initial problem here that we have, and we're going to answer a lot of questions about this particular problem. We have a cat is shot out of a kitty cannon vertically upward off the top of a 200-meter tall building with a velocity of 115 meters per second. So we see this drawing here, and we have to, before we start any problem, need to designate if up is going to be positive or if up is going to be negative. And it doesn't really matter which one you choose. You can always figure out your answers if whatever you choose. But in this particular problem, it says that the cat was shot up with a velocity of 115 meters per second. And in the problem, that's positive. So what we're going to assume is that up is going to be a positive direction, and downward is going to be a negative direction. And here's where we're starting, right here at the top of the building. So I'm going to go across here, and I'm going to have this be position 0. And so if we go up, we're going positive displacement, and as we're coming back down, we're still positive displacement until we get here to not being at 0, and then we'll come down here and we'll be at negative displacement. So if we're going up, our velocity will be positive, but it'll be getting smaller and smaller and smaller until it gets up to the top where it'll be 0. And then the velocity vector turns around, so as it's coming back down, it's actually going to be pointing in the negative direction. And so it'll come back down to here, and since this is symmetrical, however fast it was being shot up right here, which was 115 meters per second, then right here, as it comes back down and hits this exact same spot, it'll be going negative 115. Be going the exact same speed, but just in the opposite direction. And then it'll continue to go on down and become more negative. So this displacement here for this building all the way down is negative 200, because it's 200 meters down towards the negative end. So that's important to remember that for our displacement. Okay, so the first problem that we're going to look at is to what height does this cat make it? So how high up here how far up here from the top of the building is this location? How high does this cat make it? And therefore we need one of our 3 equations that has d in it, and there's only 2 of those. And you'll notice that in this whole problem here right now, we don't have time. So we want to use the distance equation that does not have time in it. And if you remember, that is VF squared equals VI squared plus 2AD. And we want to solve this for the distance. So it's going to be VF squared minus VI squared all over 2A is going to equal our displacement. So what is the final velocity? Well, the final velocity up here at the top is where we're trying to go. We're trying to figure out how high this goes up. The final velocity up here is going to be 0. So I can put in 0 there, minus my initial velocity, which was positive 115 squared, divided by 2 times a. What is a? Well, in this entire problem, acceleration is gravity, because we have a free fall problem. So acceleration is always gravity, and gravity always points down. So it depends on what we designated as down. Do we designate down as minus or plus? And you'll see down here that we've designated down as minus. So in this entire problem, gravity is going to be negative 9.81 meters per second squared. So that will always be our gravity throughout this entire problem, because we originally established as up being plus and down being minus. So gravity is always going to be minus in this entire problem. We could have totally done this different. We could have had this be minus up here and plus, and therefore our initial velocity, instead of it being 115, we would have had to say that it was negative 115. And it would be a plus 200 meters down. And then gravity, since gravity goes down, it would have been plus 9.81. So it just totally depends on how you're going to establish your signs at the beginning. So we're going to have 2 times negative 9.81. And if we calculate this out, we should have this height, and it should be a plus height because up is plus. And so you'll see that we're going to have a negative number on the top, and we're going to have a negative number on the bottom. So this is going to work out, and if I do this in the calculator, it gives me 674 meters. So I can find here from this that my drawing is pretty bad because this building is 200 meters tall, and then we shoot all the way up to 674 meters above this building. So this arc here should actually be over 3 times taller than this building is. There should be about 3 more buildings on top of this. So keep that in mind. My drawing's not that great for this. Okay, so that's the first kind of problem. We just figured out how far up this cat is going to fly. 674 meters up. All right, let's look at another problem. This time, let's look at how long it's going to take to fall back down to the same position. So how long is it going to take to fall back down to position 0? It starts at position 0, goes up. Remember, this is going to be positive, and this is going to be negative. It's going to go up to here and come all the way back down to here. And so I want to know how long it's going to take to go from up to here and back down to here. So that's time. And there's 2 equations that we have for time. We have, and we're trying to figure out, we're trying to figure out our time. So we have d equals VIT plus 1/2 AT squared. And the other one we have time is VF equals VI plus AT, the car commercial equation. So if we look at these, which one should we use? Well, I want to figure out the time to go all the way up to here and all the way back down. So do I have a final velocity? Yes, I would, because it would be the velocity that I'm going to be coming as I come down to this yellow line, which would be negative 115, because my initial velocity is positive 115 up. And here my velocity is 115 down. It's symmetrical. And my acceleration is negative 9.81. So I could figure out my time this way. So I could take time equals VF minus VI over A, and I could figure out my time. Could I do that here? Well, what's my displacement? Well, my displacement is here all the way back, and where do I end up? I end up at the same place. So my displacement is actually 0. So I could put 0 in for this d, and I could then divide this entire equation by time. So 0 divided by time is still 0, and this would just be VI, and then this would be plus 1/2 AT. And so I could take minus VI would equal 1/2 AT, and then I could say minus 2 VI all over A equals time. So I've used either one of these equations. This equation normally I don't use unless I am landing at the same spot that I started, because then I could put in a 0 for this. But imagine that we were going to go down to here or something. Well, then I couldn't put in a 0 for the displacement. I'd have to put in, like, if I went all the way to the bottom, I'd have to put in like negative 200 meters. That's how far I am away from my starting. And therefore, I'm not going to be able to just divide a time out of this, and I'm going to end up with a quadratic. So that could be kind of nasty if the displacement didn't end up being 0 there. So either way, I can do this. So if I use this one over here, my final velocity right here is negative 115 minus my starting velocity was 115. And I could divide that by negative 9.81. Gravity is going to always be negative in this problem. And I get about 23.45 seconds. It's going to take about 23.45 seconds to go all the way to the top and then all the way back here to the same level of the building. It's going to fall farther, but that's what the question asked for here. Or in this problem, I could do negative 2 times the initial velocity, which was 115, divided by negative 9.81. And you'll see that's the same math as this math right here. So either one of those I could have used to figure out how long it's going to take to fall back down to this same exact place. Okay, hopefully that problem makes sense. All right, let's do another one. Let's figure out velocities at various times from starting out here at the beginning. So let's make a little table here, and we'll have some times that we'll try to figure out, and we'll figure out the velocity at that particular time. So let's do 9 seconds. We'll do 11.7 seconds, 15 seconds, 23.4. Now you'll recognize that's pretty close to 23.45, which we just had in the last problem. So right there, we should be almost right back down to here. So this final velocity, we should pretty much make a guess right here. It's going to approximate, we're going down, so it's going to approximate negative 115. That one should be close to 115 because we're almost back down to the same spot. And then we'll do 24.5 time. Okay, so I need an equation that has time in it, and it has a final velocity in it. And the equation that has both of those in it is VF equals VI plus AT. And so if I figure out my final velocity, my initial velocity in all of these problems that this starts out is 115. So I'm going to have 115 plus my gravity is negative 9.81. And then I'm going to multiply that by the time. So I have all these times here, and I could do this first problem and put in a 9 for my time and figure out what my final velocity is. And you can see here that if if I take like this, just assume this is 10. If I put in a 9 here, I'm going to be at like negative 10 times 9. It'd be a negative 90. So a 115 plus a negative 90 is still going to be a positive velocity, which means we're still going up. So when this term here becomes more negative, greater than negative 115, then this sign will switch for my final velocity, which means I'll be up over here. If I can get this thing to equal exactly 115, like at 11.5 seconds, this is 10 and 11.5 seconds, it'll be negative 115. So my final velocity will be 0, and that means I'll be up here at the top. But as we get over that time, we're going to see our sign is going to change to negative. This term is going to be bigger than this term, and so we're going to be negative, and we're going to be going back down. So if I plug 9 in for here, and you can do this in your calculator, I'll get a velocity of about 26.71. And then if I put 11.7 seconds in here, and you'll notice in that last problem, it took about 23.45 seconds to get from here all the way up to here and back down to here, which means how much time would it take to get up here to the top? Well, it's just going to be half of that because it's completely symmetrical. It's just going to be half of that. So we're looking at about 11.7 seconds or so. So right here, when we get 11.7, if you plug that in, technically you get like 0.223 meters per second, but that's really close to 0. So that means it's plus, so we're still going up, but we're almost here to the top at 11.7 seconds. I put in 15, and I get negative 32.2 meters per second. So see, we've clearly turned around now, and we're back down on the same way. I put in 23.4, and I get really close to negative 115, which we would expect. 23.4 seconds, I'm all the way back down this spot right here, and since I started at 115, I'd be at negative 115 right here. And if you put in 24.5, we get like negative 125.3 meters per second, somewhere down here. Okay, so that's how we figure out our final velocity, or our instantaneous velocity at various times along our trajectory. Okay, Good. All right, let's do another one. Okay. Let's figure out at what times will the cat be 40 meters above the building. Okay, so now remember we already figured out this is 674 meters up here tall. So 40 meters is not going to be very high. So and there is 2 times that we're going to be 40 meters above the building, right? We're going to be on the way up, we're going to pass a place that's 40 meters above the building, and then on the way down, we're going to pass another place where we're 40 meters above the building. So there is 2 locations, and so I want to know what those times will be. So there's a couple ways we could do this. I know my displacement, and remember up was positive, and here was displacement 0, and then down was negative. So we're talking a displacement of a plus 40 meters both times. And I need to know the times that I go by these. Well, I need an equation that has distance and time in it, and of course that equation is d equals VIT plus 1/2 AT squared. The problem is now the d, this equation works well if d can be 0. If we have a displacement of 0, but we don't. We're gonna put in a plus 40 here, plus 40 meters, and my initial velocity is 115 times time plus 1/2 times negative 9.81 times time squared. And if we do this out and we put it kind of in proper order, if I put this whole term first, we're going to get negative 4.91 t squared plus 115 t. This is going to equal 0, by the way, because I'm going to take this 40 over the other side, so I'm going to have minus 40. So I need to figure out both times that I'm going to be here, and of course you might recognize why this is kind of a nasty problem, because this is t squared and t and a constant. So this is a quadratic right here. So we need to put it in the quadratic solving formula. And if you remember that, it's opposite b plus or minus the square root of b squared minus 4ac all over 2a. So in for my b, I'm going to be putting 115. And so I'll have 115 squared minus 4 times my a, which is negative 4.91, times the c, which is a negative 40, all divided by 2 times a, which is a negative 4.91. And there's a plus minus right here, which means when a quadratic c, you always get 2 possibilities. And so if I do both of these possibilities, I see that I get a time, I get one time of 0.353 seconds. And then I get a later time, which I should get a later time, of 23.1 seconds. And so that's good, because I needed 2 times. There's 2 times when I am at 40 meters above. And you'll see this first time is not very long, only like a third of a second. And that's because I'm only 40 meters off of here, and I go up 600 and some meters. So only after about a third of a second, I'm already up to 40 meters. But then it goes all the way up, starts coming all the way back down, and at 23.1 seconds after it has shot off of the roof, I would be at this location here. Which makes sense, because it was, remember, it was about 23.45 to get back down to here. So it's, a little bit less than that. It's not going to take very much time to go the next 40 meters. So this is a way to solve this problem. There might have been a little easier way to solve the problem. We could have figured out what is our final velocity at both of these places. Because the velocities at both these places will be equal, won't they? They're at the same place. They'll be equal but opposite sign. This one will be positive, and this one will be negative. So instead of doing this, I could have actually figured out my final velocity at those locations first. So if you don't like doing the quadratic, there is another way. You can just use 2 equations. You'll always have to use two equations to avoid using the quadratic. So I could have had final velocity. So final velocity squared equals the initial velocity squared plus 2AD. And so the final velocity would have equaled the square root of VI squared, and my initial velocity on this building was 115 squared, plus 2 times negative 9.81, I'm going to run out, times a displacement, which is 40 plus 40 meters. And so I could have solved for this final velocity, and it's a square root, which, what does that mean? That means there's always two possible answers. You can have the plus form and the minus form. And so if I did this and figured out the final velocity, I would have 111.53. And my other answer would be negative 111.53. So on the way up right here, I'd be going 111.53, but on the way down right here, I'd be going negative 111.53. And then to figure out the times at these locations, I could use time equals VF minus VI over A, right? Because I know my initial velocity is 115, and my final velocity here on this first place would have been positive 111.53. That would give me a negative number, and I divide it by negative 9.81, and I would get this time right here. Or I could put in initial velocity still 115, but I could put a final velocity of negative 111.53 divided by negative 9.81, and I would get this time right here. So I could use it in one equation and do it the quadratic way, get my two times. Or I could actually figure out the final velocities at both these locations and then use that in this other equation. So this is the third equation that we derived originally. And now I could put it into this equation here, the car commercial equation, to figure out my time. So there's kind of two ways to have done that problem. All right. There's a lot of questions about this. This is going to be a long video. So, okay, so let's get rid of that. And let's do another one. Let's say, at what time will the cat hit the ground? I want to know how long it's going to take for this cat to hit the ground. And if you remember, this is position 0, so we're starting here, and we're going to end up, we're starting here, about this location, and we're going to end up down here. And up was positive, and down was negative. And so we have a distance from here down to there is negative 200. And I want to figure out how long it takes time-wise. And my initial velocity is still going up at 115. So I could use d equals VIT plus 1/2 AT squared. And my displacement is going to be negative 200. My initial velocity that I shoot off of the building is 115 positive times t plus 1/2 negative 9.81 times t squared. And I'll be able to figure out my t, but you'll notice again, like the last problem, this will be a quadratic. So, and you can do that. You can put it into the quadratic, and you could figure out what time you're going to get. Now, in this case, you're going to get two times. You always get two times the quadratic, but you're only going to get one that's valid. So you're going to probably get a negative time answer, and negative time makes no sense in physics. So the positive value of time will be the correct answer to get this all the way down here. But there's, of course, other ways that we can do this one too. So maybe a better way will be to use VF minus VI over A equals T. So what we need to do here, first of all, would be to figure out what is my final velocity down here. So we can do this kind of like we did in the last problem. If we can figure out the final velocity when it hits down here, then we could put it into here and figure out the time that it takes to go all the way there. So I could be using, again, VF squared equals VI squared plus 2AD, because I have all these things. So I could do VF equals the square root of VI squared. My initial velocity was 115 squared, plus 2 times negative 9.81 times my displacement is negative 200. I want to figure out how fast I'm going to go when I'm at negative 200 away from where I started from. And so I could plug all this in, and I would get a final velocity, and the final velocity is about negative 131. Now you're going to take a square root of this, so you're going to get two velocities, but we have to know that it's the negative one because we're going down, and so it's going to be the negative 131 would be my velocity. And now to figure out my time, instead of using the quadratic, I could use this equation right here, and my time would equal my final velocity, negative 131, minus my initial velocity, 115, divided by my gravity, which is negative 9.81. And when you figure that out and put that in the calculator, you get about a little over 25 seconds, 25.09 seconds or something like that. Okay, so that would be, if I wanted to figure out the time, I could just go this way, use one equation, do quadratic, or I could actually figure out my final velocity down here at the bottom first using this equation, and then plug that into the car commercial equation to figure out what the time would be. Okay, good. So let's do one more problem. And so let's figure out where will the cat be? So distance, displacement. Where will the cat be after? So let's make another chart here. Where will the cat be after various times? So let's just look at like 20 seconds, and let's look at 25 seconds. Where will the cat be after 20 seconds, and where will it be after 25 seconds? If you remember again, this is 0, and up was plus, and down was minus. And so we are looking for D, and we have time, so the equation that we're obviously going to use is D equals VIT plus 1/2 AT squared. And so I'm trying to find out D, so I can just plug in D equals my initial velocity up was 115. And the time I'm trying to look at is 20 seconds later, plus 1/2 negative 9.81. And the time was 20 squared. And so I can just plug all that into the calculator. It's nice and easy. And my displacement is 338 meters. So this is interesting. This tells us something. This tells us we have a positive displacement, which means we're up here somewhere, right? We're up here. And we know that, from earlier problems, we know that it took like 11.7 seconds to get up to the top, and about 24 something seconds to get right down here to the bottom. And so therefore we have 20 seconds, which means we're somewhere right here in the fall back down, but we're still in the positive territory, positive displacement territory. So if we put in 25 now in here, that's going to end up making this section more negative, because we know that 25 seconds means we're past the top here, and we're going to be down somewhere down here. So if I figure out that one, D equals 115 times 25 plus 1/2 times negative 9.81 times 25 squared equals, and if I put that all into the calculator, I get negative 191 meters. So what does that mean? That means I'm down here in negative territory. And if you remember, the building was only 200 meters tall. So we're at negative 191. So we're all the way, really almost down here to the bottom. Remember, the total time it took to get from here to all the way to the bottom, we did that earlier, was like 25.09 seconds. So 25 seconds puts us almost ready to hit the ground, gives us a displacement of negative 191 meters from where we started. Okay, so that was like a nightmare problem, just one problem up here, but we answered about everything we could possibly answer about that cat flying through the air. So that is definitely a QED worthy problem.